All right, welcome back. We are jumping into these last two sections from Chapter 5 that I think are important before we move on to Chapter 6. What we are doing today is something called indirect proofs. Indirect proofs. And these type of proofs are completely different from anything that you have ever done before when we talk about proofs. It's not like proving lines are parallel, and it's not a two-column proof. It's more just using logic in this odd indirect way to be able to prove something that you want to prove. So let me go ahead and show you an example of something that can be proven using an indirect proof. So right here, it says start thinking. You find out your parents are going to Baghdad. You are not sure if they are going to Baghdad, Arizona or Baghdad, Iraq. You do know that your parents don't have passports. Which Baghdad are you going to? And we're not going to make this super confusing. We're just going to pretend like there are only two Bagdads in the world and they're both spelled the same. Baghdad, Iraq and Baghdad, Arizona. Yes, there is a Baghdad, Arizona. So one thing you could do is go directly at proving that your parents are not going to Baghdad, Iraq. Okay? So that would be just going straight forward and trying to prove exactly what you are trying to prove right off the bat. Now, what an indirect proof does is it goes over and says, okay, if there's only two different possibilities, I'm going to show that this one is not actually possible, therefore that one must be true. If you only have a select number of possibilities and you can show the other ones are impossible, then what you are trying to prove must be true. Let me explain that using this example right here. So instead of going over and going straight to proving that your parents are going to Baghdad, Arizona, what you would do is you would assume the opposite of what you're trying to prove. So the opposite of what you're trying to prove, which is that they're going to Baghdad, Arizona, you would want to go over and say, temporarily assume that my parents are going to Baghdad, Iraq. If they're going to Baghdad, Iraq, what do you know they need? If they're going to Baghdad, Iraq, you know they need a passport. Then you would go over and state the fact that they do not have a passport. You can see that this thing is a contradiction. They need to have a passport, they don't have a passport. Therefore, the temporary assumption must be false. They can't be going to Baghdad, Iraq. So the only other option is that they're going to Baghdad, Arizona. Okay? So an indirect proof, indirect reasoning is a way of proving something is true by showing all other options are not possible. Now, my wife would call this the who left their socks in the kitchen proof. Okay, let me go ahead and explain this to you. So when I get home from work, usually I go over, get into the kitchen, I take off my shoes, take off my socks, throw them down on the ground, go over, grab a nice LaCroix flavored water, and sit on the couch and relax. My wife comes home later and sees the socks. Rather than going over and saying, Paul, stop leaving your socks in the kitchen, what she does is she says, so there's some socks in the kitchen. I would assume that they were mine, but they can't be mine because mine all have flowers on them, so they can't be mine. Then I assume they are Wyatt, my son Wyatt, but Wyatt's socks are much smaller than these. So the only possibility is that they are yours, Paul. See, so instead of going over, of course, this was just passive aggressive, but this was an example of a indirect proof. If these were the only three possibilities, that they're either my wife's, my son Wyatt's, or mine, if she can go over and show that it's impossible for them to be hers, it's impossible for it to be my son's, then the only other option is that they're mine. Now, this type of proof is great when you only have a few possibilities. Let's say that this scenario took place and there were 20 people living in the house. This would be a horrible way to prove something was true by going over and showing that the 19 other people, it definitely wasn't their socks, so it must be mine. You would want to probably, the most efficient way would be going straight to what you're trying to prove. Whereas if there's only 3 cases and you're trying to prove something is true, it's not that hard to go over and show that one is impossible and that the other is impossible. So what you are trying to prove must be true. Okay, so there's some steps to doing an indirect proof. Just like HL had these weird little steps that you had to do, you had to say that the triangles were right. There's certain steps that take place in an indirect proof. Step 1 would be temporarily assume the opposite of what you are trying to prove. Sometimes there's going to be multiple things, like there's not just an opposite of it not being my socks. There were 3 options here. But a lot of times when you're doing proofs, there's only 2 possibilities. So you would temporarily assume the opposite of what you're trying to prove, knowing that it's false. You would find a contradiction and state it's a contradiction. Once you are done with that, you can go over and say, my temporary assumption is false, and what I'm trying to prove must be true. So an easier example of this would be, let's say the only 2 people who lived at my house were my wife, June Lee, and me, Paul. Okay? If she was trying to prove that they were my socks, then, and she wanted to do an indirect proof, she would go over and temporarily assume that they are her socks. Then you run through logic finding a contradiction. So then she says, but all of my socks have flowers on them, and these do not have flowers. Therefore, this is a contradiction, and my temporary assumption is false. They're not my socks, and therefore they must be Paul's socks. And there you go. That's it. So what we're going to do now is we're going to be looking at some different examples, because before we jump into like a legit full proof, I want you to understand the concept of what you would temporarily assume and what a contradiction is. So here, if you were trying to prove that a triangle was right, there's 2 different ways you can do this. You could go over and temporarily assume it is obtuse, find a contradiction, and then temporarily assume it is acute and find a contradiction. That would be the opposite of that it's right. A different way is temporarily assume it is not right. So what is the temporary assumption? If you are trying to, in the end, prove that 2 figures are congruent, what would you first temporarily assume? You would temporarily assume they are not congruent. That's the opposite of them being congruent. Line K is not parallel to line P. If that's what you're trying to prove, what is the temporary assumption, which is the opposite? Temporary assume they are parallel. And even times an even is an even. What would be the opposite? Temporarily assume an even times an even does not equal an even. Okay. The square of any number is positive. What's the opposite of that? Temporarily assume The square of any number is not positive. So that's the concept of assuming the opposite of what you're trying to do. Okay? So once you have temporarily assumed the opposite of what you're trying to prove, you would run through using logic until you found a contradiction. A contradiction are two different things that cannot happen, okay, together. So, for example, if we looked at this, which one of these contradicts this? What contradicts the fact that AB is parallel to FD? Is it impossible for them to be parallel and congruent? No. Look at these. Those are parallel and congruent. So that does not contradict it. But you can see here it is impossible for them to be parallel and for them to be perpendicular. So that would be a contradiction. If you got to a point in one of your indirect proofs and you already stated temporarily assumed that they are parallel and then you showed that they were perpendicular, you would say, this cannot be. You cannot go over and have them being parallel and perpendicular. Therefore, this is a contradiction. Triangle ABC is isosceles. Okay, so which one of these, knowing that isosceles means exactly two congruent sides, which one of these, A or B, contradicts it? Is it impossible for it to be isosceles and equiangular, or is it impossible for it to be isosceles and right? If you said right, that is not correct because you could have a right angle here and those being congruent, and now it's isosceles and right. So that is not a contradiction, but it is impossible for it to be isosceles and equiangular because if all of the angles are congruent, then all of the sides are congruent. So that would be a contradiction. Those things contradict one another. The next figure, blah, 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 is a parallelogram. Which one is going to contradict it? Is it impossible for it to be a parallelogram and a square? Parallelogram just means both opposite sides are parallel. If I drew a square, oh, wait a second. That's both pair of opposite sides are parallel. That's a square, so that one does not contradict it. Ah, a trapezoid. Is it possible for it to be a parallelogram where both opposite sides are parallel and it be a trapezoid? Those two things cannot happen together. They are mutually exclusive, okay? Therefore, that would be your contradiction. Okay, so what we're going to do now is we're going to be taking a look at actual proofs. Okay, now, yes, you could make these problems way more confusing. I'm trying to give you non-geometry, non-mathematical proofs so that you can kind of get the feel for proofs, but things are not very cut and dry in the real world. What I mean by that is it says, like here, John is going to Washington. John is going to be east of the Mississippi. Prove John is going to Washington, D.C. Now here's the issue. I'm sure there's a million Washingtons. We're going to assume, just for the sake of being able to do this proof, there is Washington, D.C., and there is Washington State, the state of Washington. Okay? So remember, first step of proving something. If you want to prove this one, what we do is we temporarily assume this one and show that that's impossible. Okay? So if I did this, my first step would be saying temporarily assume John is going to Washington State. Okay, what do we know about Washington State? It is west of the Mississippi. So John will be west of the Mississippi. I was so proud of myself when I learned how to spell Mississippi. Anyways, so John is going to be west of the Mississippi. But here it says But it is given that John will be east of the Mississippi. What is this? This is a contradiction, and the temp assumption is false. Therefore, E? Sure, maybe not. I don't know. Therefore, John must be going to Washington, D.C. Okay? So the most important things here are you temporarily assume the opposite of what you're trying to prove. You run through logic and find a contradiction with something else that's been given. For example, here, he would have had to be west of the Mississippi, but it was given that he was east of the Mississippi. You then state this is a contradiction, temporary assumption is false, and then you would just go over and state the only other option. Now, once again, if there was Washington, D.C., Washington State, Washington, Arizona, Washington, New Mexico, Washington, blah, 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 Idaho, Washington, if there were a million different Washingtons, we wouldn't want to do an indirect proof. Why? Because you would have to show that all the other possibilities were um, not true. Okay, got another one. Okay, got two more proofs. One of them is going to be non-mathematically, one is going to be mathematical. So the givens are Tom is fatally allergic to peanuts. My peanut M&Ms are gone. Tom is not dying. Prove Tom did not eat my peanut M&Ms. Okay, so step one, if you're trying to prove that Tom did not eat my peanut M&Ms, what is the first thing you state? You state temporarily assume what? Now, what people accidentally always do is they try to do the opposite of this. You do the opposite of what you're trying to prove. So we would say temporarily assume Tom ate my peanut M&Ms. What is it? What's given? It is given that Tom is fatally allergic to peanuts. So what should be true if we're going with this logic? Tom ate my peanut M&Ms and he's fatally allergic to peanuts. So Tom should be dying. Wait a second. But it is given that he's not dying. What is this? He should be dying and he's not dying. This is a contradiction, and the temporary assumption is false. Therefore, it's true. Tom didn't eat my peanut M&Ms. Okay, there you go. Temporarily assume the opposite of what you're trying to prove. Don't go over and say temporarily assume Tom is not fatally allergic to peanuts. You're doing the opposite of what you're trying to prove. You run with it till you find a contradiction. You state it's a contradiction. Say the assumption is false, and therefore what you're trying to prove is true. All right, last one. Okay, triangle ABC is obtuse. try to prove that triangle ABC cannot have a right angle. All right, so what's my temporary assumption? What's the opposite of what we're trying to prove? Temporary assume triangle ABC has a right angle. Okay. Therefore, it has what? Therefore, one angle is 90 degrees. What is also given? It is also given that it has an obtuse angle. Therefore, it has an angle greater than 90 degrees. Do you guys see a problem with this? You have one angle that's 90 and you have one that's even greater than 90. Therefore, the sum is what? Sum of the angles must be more than 180 degrees. But the triangle angle sum theorem states the sum is 180 degrees. This is a contradiction. I'm running out of room here. And the temp assumption is false. So what we're trying to prove goes here. Triangle ABC cannot have a right angle. Okay, so let's go ahead and do the wrap up and then we are done and done. Temporarily assume the opposite of what you're trying to prove, of what you are trying to prove. Come to a contradiction and state it's a contradiction. State that the temp assumption is false. Therefore, what you're trying to prove must be true. I want to remind you guys, this method is only good if there are a very select few possibilities. If there are two possibilities, then proving one of them is not possible by default goes over and shows process of elimination, shows that this one must be true. Now, if you had 10 different possibilities here, you would not want to do an indirect proof because then you would have to show that 1 doesn't work, 2 doesn't work, 3 doesn't work, 4, 5, 6, 7, 8, 9 doesn't work to show that process of elimination, that what you're trying to prove is true. All right, there you go. That is a different type of proof. Use that logic in the real world only if there is a very, very select number of possibilities. All right, thanks for watching.